Welcome to the third video in the series called Video Standards, Signals, Formats, and Interfaces. Today you will learn more about real-world colors and how they relate to the colors of the video world. You will learn about the illuminance of particular color temperatures and what is behind the expression color balance. All objects captured by a video camera can be split into three major categories: light-emitting objects, light-transmitting objects, and light-reflecting objects. For example, the sky is a light-emitting object, but the sea's surface is a light-reflecting object. Color values of the reflective and transmissive objects depend not only on their spectral reflectance or spectral transmittance, but also on the spectral power distribution of the chosen illuminant. So there's no point in talking about their colors without the full specification of the illuminant. Changing the illuminant means changing the objectively measured color. It's as simple as that. A standard illuminant is a theoretical source of visible light with a specified spectral power distribution. Standard illuminants provide a basis for comparing images and colors recorded and viewed under different lighting. They're traditionally designated by a letter or by a letter number combination, such as A, B, C, D65, etc. The color temperature of a light source is the temperature of an ideal black body radiator that radiates light of a color comparable to that of the light source. For video production, the most important is the D65 illuminant. Its spectral power distribution is close to an average, mostly cloudy midday light with a correlated color temperature of 6504 K, often called simply 6500. Only the light sources with color temperatures of about 5000 to 6500 K can be recommended for outdoor video production. So-called warm colors, yellowish white through red, actually have cooler, lower color temperature values. This often leads to confusion. If you select the daylight mode for your video camera instead of the default auto mode, then without auto balance correction, only one of three images captured in different lighting conditions will exhibit good color balance. Our eyes and brains have a wonderful ability to autocorrect white balance errors, but only in the darkness of a home theater or movie theater where we are not simultaneously seeing any undistorted familiar objects such as reference colors. In the darkness of a theater, all three perceived images exhibit good color balance. But in a relatively well-lit living room full of familiar objects like wallpaper, furniture, and so on, this wonderful ability disappears, so only one of the three images exhibits good color balance. Color balance is a generic term encompassing multiple components, which we'll explain later, and even multiple understandings. For our creative guy, it's one more way to create a desired artistic impression or a mood. But for the video engineers, especially for those responsible for quality assurance and quality control, it is, first of all, a group of important technical parameters to control and keep in good, healthy condition. At the end of the day, both guys have good reasons. It's simply two different points of view on the same subject. For the creative guy, color balance of this image is of secondary importance. The most important for him is the content, meaning the visual message. But for the video engineer, all components of the image color balance are equally important, so he should check and report all of them. We measured this image's parameters using VideoQ's VQV software viewer analyzer. The results are good RGB range for nearly all frame lines, uniform light levels histogram, full RGB range and quite strong, RGB and UV median levels offset, caused by blue color domination, UV vector scope showing 55% chroma peak volume, and distinct presence of 40% saturated red, brown, and 20% saturated blue colors. This video was prepared for you by a team of experts. Produced and narrated by Joseph Mark, a member of SMPTE's HDR committee. Written by Dr. Victor Steinberg, co-founder and president of VideoQ, technical awards winner and author of the Video Standards book. Conceived by Roderick Snell, co-founder of Snell & Wilcox and winner of several technical Emmys and Queen's Awards. Technical consulting by Maxim Levkov, author of the Video Encoding Cookbook. This video series is brought to you by VideoQ, and you can download these slides and this video from VideoQ.com. VideoQ makes products and services for all sorts of video and audio processing and quality assurance. Based in Silicon Valley with software developers and distributors in several countries. Thank you for watching.